Hello, my name is Mengqi Huang, a PhD student at the University of Science and Technology of China. Today, I will introduce our CVPR paper, Masked Vector Quantization for Autoregressive Image Generation. In this paper, we focus on the popular vector quantization-based autoregressive modules. Existing VQ-based autoregressive modules follow a two-stage generation paradigm. That the first stage learns a codebook to encode images as discrete codes. The second stage learns to generate codes autoregressively, which are then restored to images. However, existing codebook learning simply models all local region information of images without distinguishing their different perceptual importance, which brings redundancy in the learned codebook that not only makes the autoregressive model in the next stage overly focus on modeling this redundancy while overlooking other important regions and finally degrades generation quality, but also result in high training cost and slow generation speed. We propose to relieve model from redundancy by only modeling important regions information. According to the classical image coding theory, the difference of important and unimportant regions lies in whether they can be restored if missing. That is, the important regions are those cannot be restored if missing. Our important regions only modeling could bring better generation quality, since the autoregressive model in the second stage could focus on modeling these important regions, and faster generation speed, since redundant codes are removed. As shown in the left figure, the codebook learning only includes the important regions, like the structural regions, since the unimportant ones, like the background, can be restored even if missing. Next, we will introduce our proposed novel two-stage framework, which consists of a masked quantization, VAE, and SEC former to relieve the model from modeling redundancy. In the first stage, the distinction of important and unimportant regions is achieved by mask mechanism. That is, the masked part is important if it cannot be faithfully restored and otherwise unimportant. Therefore, we propose a novel adaptive mask module for adaptively masking redundant region features before quantization, and a adaptive demask module for adaptively recovering the original grid image feature map to faithfully reconstruct original images after quantization. To be specific, the adaptive mask module adopts a lightweight score net to measure the importance of each region, and select top-end regions as important regions for quantization. As for the adaptive demask module, we first pad masked regions with a learnable mask token. Then we propose a novel direction constraint self-attention to encourage the image information flow from unmasked regions to the masked ones while blocking the reverse. The attention mask is illustrated in the left. Considering that the mask token is updated with more and more information after each iteration, we further propose to amplify its interaction with other codes step by step through a mask updating mechanism. Next, we introduce our second stage model, StackFormer. Since the perceptual important regions of different images vary, we propose to learn the combination of the codes and their positions at the same time by stacking a code transformer and a position transformer. To be specific, the code transformer learns to predict the next code based on all previous steps codes and their positions, while the position transformer learns to predict the next code's position based on all previous steps position and current code. Next, we show our experimental results. For unconditional generation, we significantly outperforms other autoregressive models with the same parameters. We also compare with other types of unconditional state-of-the-art and large-scale big models where we achieve top-level performance. For class conditional generation, we achieve the best FID score compared to all types of models. We also achieve top-level performance with fewer parameters compared with large billion-scale models. For text conditional generation, we compare with existing text conditional state-of-the-art without actual web-scale data or pre-trained models on MS COCO, and shows we achieve significant improvement compared with BQGAN. We show some generation sample of our model. Finally, we visualize our learn mask, which validates that our proposed adaptation mask mechanism successfully learns to preserve the perceptually important image regions, that is, the structure and edge regions of objects. Thanks for your listening.